Triangles. A triangle is the most commonly found figure in geometry. It is widely used in applications like engineering, architecture, mechanical drawing, etc. Since the shape of a triangle cannot be altered without changing the length of its sides, therefore it is used to give rigidity in almost all constructions, especially when making bridges and towers. In this topic, you will be learning about the types of triangles, their properties, and the relation between various angles of a triangle. A triangle is a three-sided closed geometrical figure formed by joining three non-collinear distinct points. The 3 points, say A, B, and C, are called the vertices of the triangle ABC. The 3 line segments AB, BC, and CA are called its sides, and the 3 angles, angle BAC, angle ABC, and angle ACB, are called the angles of the triangle ABC. This is the symbol used to denote a triangle. We read this as triangle ABC. The 3 angles of a triangle ABC are denoted as angle A, angle B, and angle C, where angle A stands for angle BAC or angle CAB, angle B stands for angle ABC or angle CBA, and angle C stands for angle BCA or angle ACB. The 6 parts, namely the 3 sides and the 3 angles of a triangle taken together, are called the 6 elements of a triangle. The sides AB and AC meet at the vertex A. Therefore, BC is the side opposite to the vertex A. Similarly, the sides AB and BC meet at vertex B. CA is the side opposite to the vertex B. And the sides AC and BC meet at vertex C. AB is the side opposite to the vertex C. A triangle divides a plane into 3 distinct parts. These are the interior part, the triangle, and the exterior of the triangle as displayed. The triangle ABC together with its interior is called the triangular region ABC. Read the statement and click on the correct option to continue. Let's now look at the properties of a triangle. Angle sum property. The sum of all the 3 interior angles, that is, angle A, angle B, and angle C in a triangle ABC equals 180 degrees. Activity 1. Given here are some triangles. You know that the sum of the angles of each triangle is 180 degrees. Drag and drop the numbers to indicate the measure of the third angle in each triangle. Property 2. In a triangle, an exterior angle equals the sum of 2 interior opposite angles. This property can be verified with the help of an example. For example, let's consider a triangle ABC where the magnitude of angle A is 30 degrees and that of angle B is 40 degrees. You need to find the magnitude of the exterior angle ACP. From property 1 we have angle A plus angle B plus angle C is equal to 180 degrees. 30 plus 40 plus angle C is equal to 180 degrees. Angle C is equal to 180 minus 70. Therefore, angle C is equal to 110 degrees. You will recall that angle C and angle ACP are adjacent angles and form a linear pair. You will also recall that two adjacent angles forming a linear pair are supplementary angles. Therefore, the sum of the angles ACB and angle ACP equals 180 degrees. Since we have already calculated the magnitude of angle ACB, we can thus calculate the magnitude of angle ACP as angle ACB plus angle ACP is equal to 180 degrees. Angle ACP is equal to 180 minus 110. Therefore, angle ACP is equal to 70 degrees. You can see that the magnitude of angle ACP equals the sum of angle A and angle B. Therefore, in a triangle, the exterior angle equals the sum of two interior opposite angles. Property 3. The sum of any two sides of a triangle is greater than the third side. You can verify the result of this property either by observation or by actually measuring the lengths of two sides and finding their sum. Let's take an example to verify the result of this property. The lengths of the three sides AB, AC and BC of a triangle ABC are 2.5 centimeters, 2.5 centimeters and 3.5 centimeters respectively. Since the lengths are given, we can verify the property as AB plus AC is equal to 2.5 plus 2.5, that is equal to 5 centimeters. The length of the side BC is equal to 3.5 centimeters. Therefore, the sum of the sides AB and AC is greater than BC. Similarly, we can consider any two sides of a triangle to arrive at this result. Complete the given statements by keying in the correct word or number. You just looked at the properties of a triangle. Next, you will look at the classification of triangles. The classification of triangles is based on two factors. These are the lengths of the sides and the magnitudes of the angles. The triangles are classified according to the lengths of the sides. Since a triangle has three sides, three conditions may exist. Either all the sides are of the same length, two of the sides are of the same length, or none of the sides are equal. Let's look at each of these in detail. Scalene Triangle. None of the sides of the triangle are equal to each other. For example, the length of the three sides of a triangle ABC are 1.5, 3.5 and 4.5. This is a scalene triangle. Isosceles Triangle. A triangle having two sides equal is called an isosceles triangle. Two sides of a triangle ABC measure 3 centimeters each, and the third side measures 4 centimeters. This triangle is an isosceles triangle. Would you believe that angle B is equal to angle A? Perhaps you could try it out for yourself. Equilateral Triangle. A triangle having all sides equal is called an equilateral triangle. All the sides of triangle ABC measure 3 centimeters. Thus, ABC is an equilateral triangle. According to the angles, the triangles can be classified as acute angled triangle, right angled triangle, obtuse angled triangle. Let us look at each of these in detail. Acute angled triangle. A triangle, all of whose angles are acute, is called an acute angled triangle. You will recall an acute angle is that whose magnitude is less than 90 degrees. For example, if the interior angles of a triangle ABC are 60 degrees, 45 degrees, and 75 degrees, then triangle ABC is an acute triangle. Right-angled triangle. If one of the angles of a triangle is a right angle, then the triangle is a right-angled triangle. For example, in triangle ABC, angle B is equal to 90 degrees. Therefore, it's a right-angled triangle. Carpenters find this angle very useful. Do you notice that all furniture make 90 degrees with the base? The table with the legs, the shelf with the wall, the edge of the door, to name a few. Obtuse angle triangle. A triangle one of whose angles is obtuse is called an obtuse angle triangle. You will recall that an angle having magnitude greater than 90 degrees and less than 180 degrees is called an obtuse angle. For example, in triangle ABC, the magnitude of angle A equals 110 degrees. Hence, triangle ABC is an obtuse angle triangle. Match the columns. Quiz. Click on the corresponding option in column B. Think it over. A landowner died leaving his estate, which unusually was in the shape of a square, to be shared among his wife and 4 sons. His wife was to have the quarter of the estate indicated by the triangle on the plan, while his will decreed that the 4 sons should share the remaining land in such a way that each one of them had areas identical in size. Help the sons determine their inheritance. We now have 4 large triangles and 4 small triangles to be distributed.